Okay, before you're able to do the left 10 or 11 or a little more, you have to get the understand basic on the software. That's very important to know about what we're talking about, the function. Okay, now, first thing I want to ask you. Okay, what that means? What is it for the first one, Nancy? Can you tell me? First one, integer Nancy. What is it? What Nancy?
Is a dress named Nancy as for defined as an integer.
You have to say that on software, this is a variable, correct?
Yeah, variable.
Okay. If you're talking about the hardware, that will be a threat. Okay. So basically later on, you can say Nancy equal 30, right?
Mm-hmm.
That means you store the value 30 into the thread of the variable Nancy. Okay, the second one.
That's just a function, right?
Exactly. That is the function. Okay, anything, anytime you say open and close, they must be the function. Okay, that's what we're talking about today. And the last one, Nancy.
Array.
Exactly. That will be an array. Okay, if I say 42, what that mean? That means they get the location from 0 to 42.
So there's 0 to 42 things that you're going to be listing.
Exactly. That means you can store from 0 to 42 address. That's a different from with this guy. Integer Nancy, you can store only one value into only one address or location. Okay. Only thing is when you're looking into the file, you're able to recognize they just a variable, or they can be a function, or they can be an array. Okay. Now, I go quick. The thing is we don't have enough time. What a function is and what is part are. How to declare and define the function. You have to say, you have to try to understand declaration and define data different. Okay? You know what the declaration?
The declaration is, well, I'll just say it this way. It's the part where you go void, whatever else with the parentheses and end with a semicolon. And then when you remove the semicolon, it becomes the function definition. And then when you put the guts of it between the void, then that's what you call the function.
Okay, now to make it clear, declaration. That means you have to tell the compiler you get a function.
Mm-hmm.
Okay, and definition. That means what you doing in that function.
Mm-hmm.
Okay, so if you get the declaration, then you must have to get the define.
Mm-hmm.
Okay, the function. Otherwise, you get the error right away. Okay. Now, and now they're talking about how to pass parameter into the function and how to return a value from a function. Okay, a function is sub-program that can be act on data and return a value. Anyone want to learn it? Software, then you have to really understand the function. Okay, the thing that they don't want to write in a big program. Okay, they try to make a small program. Each program will do something, and they can combine. Okay, every C++ program has at least one function. That is the main function. Okay, main equals automatically when the program starts. Main may be called other function. Okay, some of which may call still order. That means you need it, you can call the function. Each function has its own name, and when that name is encountered, the execution of the program branch to the body of that function. That means when you call the function, okay, so the program will be jump into the definition, the define of the body of that function to do things. Okay. When the function return, execution resume on the next line of the calling function. That's a very, very important for everyone try to understand what's going on. Okay, we try to summarize what really you need in order to do your program. Well-designed function perform specific and easily understood tasks. complicated task should be broken down into multiple functions, and then it can be called in turn. Okay, that means you can call too many functions. Functions come into variety. You define, built-in. You define, that means you wrote your function. Built-in, that means Microsoft did it for you. Okay, only thing is when you're using the function, you can call that function. I give you an example. You solving the equation x squared minus 2x plus 2 equals 0. You want to solve that function. Then you have to be include math.h. That means the function that will be helping you to do. Okay, declaring and define function. Using function in the program required. First thing you have to declare the function and also define a function like I already talked to you. Make a declaration. Then you have to define the function or the body of the function. The declaration tells the compiler the return type, the name, and the parameter of the function. The definition tells the compiler how the function works. No function can be called from any other function that hasn't first been declared. Okay? If you not make a declaration of that function, they cannot work it. Okay? The declaration of a function equal a prototype. Either way, we can say prototype or declaration. Not a big deal. There are two ways to declare function. Write your prototype into a file, and then you include directly to include in your program. Write the prototype into file which your function yield. Okay, now you understand the prototype or declaration. Okay, I can say integer, okay, write to memory. Okay. Now you can see they're talking about declaration. Just a minute. Okay, now I'm telling you in general. First thing, you can say whatever in the declaration. You say include, okay, and IO still not ATT, okay, IO. Okay, then you can put your declaration. I can say void. Okay, write to memory. Okay, so that's just a function decoration. And later on, we have to get the right to memory, okay, definition. So now you can get too many in here. However, you start your program with void man. That means only one program, even you don't have it, they're still there. They must be there. Then you must be open the press. You can do whatever in here. And you must be closed. You say, and man. Okay, so after and man, what's supposed to be?
Function definition.
That will be function definition.
Without the semicolon.
Yeah, that will be get into that detail. But general, I just telling you, the program will be organized this way. First thing, you have to get a decoration, anything, variable, okay? Function decoration. Then you start with the main program. So whatever you want to do, they will be inside the main program. And after the end of the main, and now this is the area for function definition. You can say on the function prototype, you get the right to memory. Then function definition, you can get the same thing, void. Okay, right to memory. But no semicolon. Okay? Then you can open the press. Inside here, you have to do something to able to write the data right to the memory. Then you close. That means function definition. If you get the decoration, then you must get the function. If you get a function decoration, you have to get function definition of the body of the function, what you want to do, in drive to the memory. That in general, okay? If you get a confusing anything, just stop me, okay? And now, in here, what they said in here, function come into two variable. Let's see, that one we done. Okay. In here, they say function decoration. Okay, that means you want to declare your function. You will write your prototype into a file, and then you include directly to include it in your program. Or you write the prototype into the file in which your function is used. Okay, anyone understand the first one? What that mean? How can we do? You understand a function prototype, just telling the compiler what the name of the function prototype, parameter, anything. Now, in here, they say you can write the prototype into a file. And later on, you're using include to include that file into the program. Why they want to do that way? Okay, the reason they using this way, the thing is, sometimes one prototype they can be using to too many different functions. So they don't have to write again. Okay, like your banking, they get a function, okay, definition and function prototype, like to go deposit or withdraw, each function different. But they can put it in only one file for the decoration. And when they're using, they just include into the program. So that they don't have to type in again. Okay, and normally we do it, write the prototype in the file which your function is used. That's what we normally do it. Function prototype. Function prototype is a statement which means it ends with semicolon. It consists of the function's return type, the name of the function, the parameter type, and the parameter name. For example, you see that function prototype does not need to contain name of the parameter. Example. Example here first, okay. Unsigned short integer. That is the type. If we learning introduction, we can say type will be integer, unsigned short integer, long integer, okay, or float or double. That is the type. File area, the name of the function. They can be any name. Then they open. They get a true, okay, variable. They get the integer length. Length will be the name, first variable. Integer means the type of length. Integer width, that means the type of width, okay? That means parameter type, parameter name. Another way, same thing. However, they not require the name of the variable. They just integer, comma, integer. They're telling you they get two variables, but don't have to be the name of the variable. But the first one much better. The thing is that more clear when you're reading it. A parameter type must be separated by comma. Okay. Adding parameter name make your prototype clearer. That's what I said. I like the first one. Make more clear. If none, explicitly state the return type default to integer. That's like telling you, if you say just a length, okay, just a name, you don't have a type, okay, automatically they given you integer. That's what they said. Function definition. Function definition of a function consists of function header or declarator. That means the first line, they call it declarator. And the function's body, the header is exactly like function prototype, except that the parameter must be named and there is no terminating semicolon. Okay? If I want you to write a function definition, then you have to understand in order you can write without any error. The body of the function is set of statement and closed in the brace, open and close. If function return a value, it should end it with a return statement. Okay? A lot of students don't understand what they mean for return. Same thing like when I start learning this program, I couldn't understand what they mean for return statement. Okay? But we'll be help you out. If function return value, it should end it with a return statement. Return statement can legally appear anywhere in the body of the function. Every function has return type. If one is not explicitly designated, the return type will be integer. Okay? If a function does not return a value, its return type will be void. Okay, so that's why normally you can see on most of the function or the main function are using void. Void means they not return anything. A function can take any number of parameter or no parameter at all. Okay, so that's why sometimes you say I get a function here. Okay, void. Okay, right. Address. Joe. Memory. And I open here. Okay, I say integer ADD. First thing, you can see they say void. That means this function not return anything. However, this function get a one variable, integer ADD. So when you in your function definition, you want to write, okay, address 0xAA. That means you have to say write address to memory. And you open here, you put ADD. Okay. So in that function, if you say 0xAA, so they will be substitute for ADD. If you don't want anything, then you don't have to put any variable. Okay. Let's see. If a function has return type void, cannot return a value. Function can take any number of parameters, but can return only one value. Variable can be passed to the function by value, by a pointer, by a reference. If you really want to learn more in the software, then you have to get through it. Okay? In the D lab, we're using only by value. Okay? Now, try to see this very simple program. They get a function here. That's what we call a function prototype. Integer area, integer L, integer W. That function definition, return type, integer. Name of the function is area. Two parameters. First integer L. That means L will be type integer. Integer W. W will be type integer. That function prototype. Okay. And the function prototype, then you must get the function definition. You see right here. The function definition. The first line copy exactly the same. Okay. In the function prototype. Integer area. Integer L, integer W. Okay. If I don't want that thing, I can say integer. Okay. A. Integer. B. Is it okay or not?
And Mr. Pham, so you're asking if you can change the L to an A and the W to a B.
Right, that's what I said. Is it okay or not okay?
Let me see.
You can change it, but the bomb Z equal to A.
No.
and B.
Right now, we're talking about the first line of the function definition.
Mhm.
What I'm saying is, normally, they will be look like the function prototype.
They have to be the same, except for the
No.
semicolon.
No, it can be different.
Okay.
Is it they can be different or not? Yes or no?
I say it can be different. Joe say it has to be the same.
What I said the same, that means the same integer area, right? Two variable. Only thing is they don't have a semicolon. But my question right now, if I copy exactly integer L, integer W, but I say I don't want integer L, integer W, I change it integer A, integer B. Can it work it or not?
Yes.
Okay. You say yeah, that's correct. Okay. However,
In the definition, you have to change that L and W to A and B.
no, I'm not changing anything in the declaration. Right now, we're talking about function definition.
No, I mean the definition inside the parameters, you have to change that Z is equal to A times B for it to work. If you're going to change the
Okay, I understand.
Yeah.
That means in the body. You see that?
Yes.
Z equal L times W, and now I can change A times B. Right?
Yes.
Okay. But the question is, how can we able to change to A and B in the definition? How? Normally, you have to reading over until when I asking you guys, you can answer to me. Now I can tell you when you say integer L, what is L?
A variable.
A variable or address.
Right.
Correct?
Yes.
Okay, now in the program, okay, void main or the function declaration, they get a different area in the memory. And also the function definition, they also in the other area. Okay. So we'll see how they work. In the main, I said integer length equal 9, width equal 4, and integer x. That's just a define. Okay, nothing else. Question A. X equal area, length here, width here. Okay. What X equal? Equal what? When you say X equal area, that means equal the function. What that X equal?
Function area where the address length and width store the number 9 and 4.
Yeah. But the thing is right now, we're not talking about that. I'm asking about X equal area. X
So-
equal the function.
Right.
What that
So
mean? X equal what?
is equal to the return value of the function.
Exactly. That means x equal return from the function. Whatever return. Now, when they go x equal area length width, that means they passing the value of 9 and the value of 4 into the function. Okay? And when I said in the function definition, I said integer A, integer B. That means I get another 2 location in the memory. Try to contain the value passing from the function. That will be telling you in the location A, you get number 9. B, you get number 4. That would mean quite different location. Okay? Then they get inside the function definition. Integer j equal I times W. Same thing. A times B. And G will be equal 36. Correct? G equal A times B or L times W. That means take 9 times 4. You get 36. Okay? And when they get a return, right here, that means they return the value. So in here, x equal area here, after they go through the function definition, they return the value. That means x will be equal 36. That's what they mean for return. They take the value back into the program. You know, I said in the past when I read x equal area, length, and width, I could understand it all. X equal the function, that means they try to get x equal whatever return from the function. And they bring the value of x, then they will be bring number 36. That's how the function working. Any question? Okay, now, if I change the value in here, integer A or B, instead 9 and 4, I change to a different number. Like I change it to 10, I change the other one to 2. My question is, when you change in the function, okay, do they change in here? In the length and the width? Okay, they not changing. Why? They at a different location in the memory. You can change whatever here. It's not affect in the program. The thing is, they quite different location in the memory. Okay. Now, if I want when I change in here, in the program will be changing. What do you think I can do? Even you don't have to do anything with that, but for your knowledge, again, I already telling you, length and width, they are location in the main program. And also L and W in the function definition. Also they in the location, but not the same with the length and the width. So that if you change in the function definition, L and W to different value, and the length and the width in the main function cannot be changed. Length still be 9, width still be 4. However, my question is, if I want to, when I change in the function definition, they will be changed in the main. What can we do?
In the definition, the function prototype, you put integer L equal to 9, and then W equal to 4 up there.
That not make any difference. You can put it in here. Right here. L, integer L equal 9. Okay? L equal 9. W equal 4. So basically 9 and 4, the value inside L and W. Location. Nothing changed. If you go into the L and W here, I'm not talking about A and B. I'm talking about L.
Right.
Okay. Now this is still L. This is still W. However, what I'm saying is, they in the different location in the memory.
Right.
So if you put a 9 here, 4 here, okay, that not mean this will be 9 here, 4 here. This location in the function definition, they're quite different. Okay, so you guys don't know. So that's why, if you want to change the variable address here with a different value, so you cannot passing by value. You have to passing by address. So address in the main and address in the function definition, the same address. So that's why when you change value in the function definition, automatically they will be changed in the main. The thing is the same location, the same address. That's what they're talking about, the pointer Pointer means using to passing address to the memory. That's really the top one. Okay. So forget that. But that I telling you, they passing by variable. Okay, now local variable. Local variable that are declared with the body of the function. Okay, you know what the body of the function? Here, this is your function in the main. You can say integer x equal 5. So basically, x inside the open and close of the function main. So they will be local. Okay. If you put in up to decoration area, you say integer x. Then x here, they call a global. Now try to see what the difference. Anything local variable only valid inside the open and the closed brace. Okay? Any function global outside the function, they will be valid anywhere in the home program. That is talking about local and global. Okay? Local variable that are declared within the body of the function. Okay? Local variable exists only local with the function itself. When the function returns a local variable are no longer variable. The parameter passed into the function are also considered local variable and can be using exactly as if they had been defined within the body of the function. Variables declared within the function are said to have local scope. That means they are visible and viewable only within the function which they are defined. Now you understand. Local means the variable inside the body of the function. If you say integer x equals 5, and later on inside that block of code, x all the time equal 5. Okay? Global variable. Global variable that are defined outside of any function have a global scope and thus are variable from any function in the program, including in the main function. Local variable with the same name as the global variable do not change the global variable. Okay, see the different location in the memory. I already telling you. Anything in the decoration, they get a different area in the memory. Anything inside the main function, they inside another area. Okay. If a function has a variable with the same name as the global, the name refers to local variable, not the global when used within the function. That they telling you, you can get integer x Okay, that the local integer x, that the global. If you say a equal 2 times of x, they not take this guy. They have to take the 1 in the local. That's what they tell you. Okay, global variable, a words of caution. In C++, global variable are legal, but they are almost never used. Global variable are dangerous because they are share data, and one function can change a global variable in a way that is invisible to another function. Okay, global variable valid everywhere in any function. Local valid only in one function. Now, in the company, one project is not only one people do it, will be more. Okay, people will be work together. One will be doing something, a part of that, another one is doing the other part. So that's why they say, try to using local variable. Don't using global. Why? The thing is they're using a global. And on the other program, if they changing something, that variable changing can screw up everything. Okay? So that's why global, they don't want to use it. Okay, quickly to get it done. You have a function double, triple. Double means x times x, triple, x times x times x, square, x square, or cube, okay? X of which return a value. Then you could write it way. Answer equal, this is a function here, okay? Old function. Answer will be equal whatever return from the function. Okay, so the first thing, the function to go a Q, my value. Okay, that means you can get value equal 5. So if you go a Q function, so what will we return for Q function? Q, the same thing, they can be x times x times x. So that means if my value equal 5, so 5 times 5 times 5, I get a small value. I get number 2. My value equal 2. So 2 times 2 is 4. 4 times 2 is number 8. So when they execute the Q function, the return the value will be number 8. And then they call a square function. Okay? Square means they take the value from the Q square. 8 times 8 equals 64. Then they call a function triple. Okay? Triple will be equal whatever return from the square. Okay? And they keep multiply. And after you triple, you done. You return whatever value. They will be called the function double. Okay, so double, after they get a double, they will be given an answer, the value to the answer. Okay, so that means you can read in here. Okay, they try to explain to you how they work. Return value. See the following return value from function. Return 5. And another one, return x greater than 5. When they say return 5, that means they return number 5. However, if they say return x greater than 5, what they return? They will be return the logic. That means if x equals 4, return will be 0. If x equals number 7 greater than 5, they return logic 1. That means they're telling you true or false, right or wrong. Okay? And also they can say return my function. They're telling you in the my function, whatever return in the my function, they will be returned here. Okay? Default parameter, long my function, integer length, width, height. In here, you can see they get 3 variables. Type integer, the name, length, width, and height. In this function, they given you width equal 25, height equal 1. That's only telling you when you call this function, if you enter the value for the length only 1, automatically they take 25 for second, height for number 1. That's what they want to let you know.
Mr. Pham, question
Yeah,
regarding the double, triple, square, cube function. From what you explained, it sounds like it's read and calculated from cube to square to triple to double, which means it reads from right to left.
yeah, from right to left.
Right. So if all those words were flipped, cubed, where double is right now, put cube there, and where triple is, put square, and just flip it all backwards. Can you have the value where it says my value? Just
This is by value. However, you have to execute first cube function. You cannot execute the double.
right. So that you can't reverse
No,
that calculation. So answer equals cube. You can't do that. Okay, you can't say answer equals cube.
no, you can use in any order. You can say cube, square, triple. However, the last one have to get the variable name, variable value.
Right. So anywhere part of the program line, my value has to be the last part of the instruction.
Absolutely.
Right. And then, all right, I understand. Thank you.
And the order doesn't matter. Okay? So overloading function. See, man, you don't have to understand overloading function. But if I said you learning the software, you merge. The thing I spent 1 week training, pay for 1,500. After that, I couldn't understand what the overloading. Now we see C++ enable to create more than one function with the same name. This is called function overloading. And the function must differ in their parameter with a different type of parameter. You see, they get 4 functions. Double. However, parameter here different. First one, they get double integer. The next one, they get value long integer. The next one, they get 2 variable type float. Next one, they get same name, but the parameter will be double integer. That's what they call overloading. You can see in the company, they're using a lot. Like, for the payment, they can get only one name of the function. However, the payment for who? For technician, for engineering, for assembler, okay? Still using only one name is payment. However, passing any variable, they will be different parameter and a different type, okay? Then they can do it. Like, I get a function payment and technician, they can get 2 type, technician, or 3 type, like permanent or temporary, okay? That means they get a different type. That's why they have to using normally the same one name function. Makes sense. When we reading, we know, okay, this is a payment. However, payment for who? That is changing parameter, okay, in the function. Okay. Any question? Now, I go to the lab. I don't want that one. Let's see. Okay, I was talking about this one. Okay, if you're looking into this schematic, first thing need to identify how many IC. Okay, U1, U2, U3, U4, U5, U6, U7, U8, U9, and U10, right? 10 IC. And also, we need to know how each IC working. In order to know, you need to looking into the IC, okay, from the web. First one, you can see this guy, U1. Let's see. I try to see I can copy that guy. copy. Okay. Paste them out. Okay. Okay, on this IC. Okay, make it clear. This IC will be 74164 serial to parallel converter. That means the data go to A and B, serial. Say serial, they need only one wire. If you want data 0x 5, see how the IC working. First thing, MR still stay for what? Master reset, active low. If you set the MR equal 0 on the output here will be 0. You cannot send any data into the output if MR equal 0. So MR equal 0. So the input clock will be don't care. A and B input will be don't care. Output must be 0. Okay. So now if you want to send the serial into the parallel, then MR must be 1. Okay. So we'll see. You get logic 1 here. So 1 pin, 1 input AB need the clock going 0 to 1. Okay. 5 that will be telling you look like 1 0 1 0 1 0 1 0. So after 8 clock, you can get 1 0 1 0 1 0 1 0. So you can see on the left they get a serial 5. When they go to the U1, they go to number 5, but 8-bit 0 1 0 1. That will be M and B, and that will be L and B. So that will be a 8-bit in parallel. Any data you want to send to the output from serial, they will be go into parallel. And that's this software, you don't have to do anything. I already gave it to you. The function definition. If you call this function, you just say, okay, I want 0xAA, then they send AA for you. I want 0x09, they send 09. Okay, that is the first one, how it's working. So for this one, the first one you say you send 0x55. The answer here have to be 0 1 0 1 0 1 0 1. If they not coming right, make sure you can take pin 9 for logic 1. Take the clock, make sure you get a 1 clock for 1 bit, and take the input A and B. You can get the signal. look like this one. If you get the input right, then you need to change the U1. Okay, so 74164 serial converting to 8-bit parallel. Okay, next guy, U3. What U3? 541. We already talking about 541.
It's a
But the
buffer.
buffer.
It's a buffer. Whatever you put in, you should get out.
Right. Okay. That means what in the input D1, D2, D3, they will be go to Q1, Q2, Q3. With that have to be 0. Correct?
Correct. It had to be enabled.
They have to be enabled. If they enable 0 and 0, so whatever going logic 1 here, will go 1 here, 0 here, they go 0 here. Okay? Then you can see they going down. See that? Going down and they go into U2. U2 also is a buffer. However, 1 and 19, they routed ready. So whatever in here will go to the port C in the system. So for you to verify. Okay. Now, we want to talking about this guy, U4. U4 A and B. This is a decoder. Okay. Decoder, first part, they get pin 1 enable. When they route it, that means they will be enabled. And the decoder output normally 1 on 1, 1, 1, 1, 1, depending on A and B. If you set port A 0 here, 0 here, you know the first one will be 0. And that will be 1, 1, 1. Only output, one output will be low. The rest have to be high. If you change A and B to 0, 1, the second one will be low. Okay? And another change AB to 1, 0, then the next will be low. And 1, 1. Output 7 will be low. The rest have to be high. That's the only thing telling you. Only one output low depend on what logic and A and B. Any question on that? So, on the fourth test, I already telling you. The first test I want to test U1, U2, U3, U4. That's only one schematic. Okay. That means I want to test U1, U2, U3, U4. That makes, when you're reading, you know what I want to do. First thing I say, send 55, okay, into U1. Okay, then I say enable U3. That means this is a function. The function I call enable. So you know what inside enable U3. That's a function definition. Enable U3. That means I want this to be 0. This to be 0. What you have to do? Write to port
B.
B 0 0. So that's why you get 0 here. So the reason we're using the function, that will be make sure you can understand when I say enable U3. That means I allow the signal from input D to go to the output Q. That's what that means. Okay? And you can read in the output. That's the enable U3. And now you can see on U4 to get a QIC. They're using pin 3, pin 4 for A and B of U4. However, this pin PD2 not connect to the route. So they can be 0, they can be 1. My question is, if I get this into 1, what the output? Y0, 1, 2, 3 of U4B.
Or 1.
All 1. They must be 1, 1, 1, and 1. You get that? Okay. Now I'm talking about first one, Y0. If I'm talking about Y2 right here. If they get a 1, go to inverter, they will be
0.
0. Okay. So now I try to apply, let's see, 0, 0, they get the first one, 0, 1, they get the second one, 1, 0. Now I connect it to 1, this to 0. If I set enable equal 0, what happened to output Y?
Y2 go to 0.
Y2 will be go to 0. Y2 go to 0, go to inverter. They go to 1, correct?
Mhm.
Now, I set again equal 1. What happened to the Y2?
Output 1.
Output now 1 again. And 1 in here, in go inverter, they be 0. Okay, that's telling you that look like the clock, right? 0 to 1 and go back to 0. See that?
Mhm.
So in order to create a clock in here, or create number, logic one in here, you have to set this guy and you have to write to put D pin 2 3 times. 1 and 0 and 1.
Hey, Mr. Pham, my only question is, when you, at PD2, pin 15, you always start there at 0 or 1?
One,
Or you always start with 1?
yeah. The thing is you need the positive clock.
Okay,
So first thing they must be 0. That means you set the enable PD pin 2 to logic on 1. Output have to be on 1.
because PD2, the way you got the 101, that's like a negative pulse there, right? Or what?
On the other side, but not on the output of U10.
Can you draw the pulses on there so I can see that better?
They will be 1. Go 0. Go 1.
Okay, thank you.
So go inverter, they inverted.
Okay, yeah, that makes sense.
That is a big problem for the guy. Try to do it.
And Mr. Pham, at the beginning of the class, you asked if we had any questions. My only question was if you could go over test U6, U7 data.
No, not yet.
Okay,
No.
all right.
You can advance, okay? However, I just talking about very simple 4 to 10.
Okay, all right.
U1, U2, U3, U4. So what I want you to do when you build the circuit, don't build every IC. You can build related U1, U2, U3, U4. Then you can run the test, number 1, number 2. If they pass, then we nothing wrong later. U1, U2, U3, and a part of the U4. The thing is, we don't want you to build the circuitry when it's wrong and you try to looking into the wiring. No. Technician just using meter or oscilloscope to find the problem. The reason is, at work, you cannot see any wiring. Just using scope or DMM. If you want logic on 1 here, you measure, you get 1, correct? You measure here, you get 1, that's correct. Okay? And 0 here, and 0 here, so on. If you see, if you get the number 1, instead 1, you get wrong. They not 1. Maybe they can be 1.5 volt or whatever. That's not logic 1. Then you have go back to U1 pin 3. If in U1 pin 3 you get a 1, guarantee the wiring get a problem. Then now we're looking into the why. Okay? Okay, so now you can see in here, you get this is the memory. Okay. However, I'm going back with the Excel. Okay. Okay, we'll see on that. First thing, you can see here, that's what you need to do. You can see I given you the tab number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. What you need to do. This is what you have to type in your function declaration. You get enable U3, U5 latch, U6 clock, U6 output enable. That U6, U7 integer data, whatever here. That will be typing in the function declaration. Okay? And now, this is the function definition enable U3. In that function, I'm telling you, you need to write to put B. Then you need to enter data here. So, for my understand, on that one, I just typing 08. Zero. You see that? If they say part, that means that function definition good. The thing is on the function definition, you want U for A, that's the first one. You want it to be 0 and 0. So that's why I get 0, 0, 0. Now, the next function, U6 output enable. Look into that one, U6 right here. Okay, U6 output enable pin number 1. Go to U4 pin 5 right here. So now you have to set that to be a 0. So you know what the PA pin 1, pin 2, what's supposed to be?
Zeros for PB1 and PB2 should be zeros. So that YO will be 0.
No. Right now, what I said, I want U6 pin 1, 0, right?
That's what I said, Mr. Pham.
Okay, U4 pin 5 right here. What you writing to PA1?
Oh, that's Y1, Y1.
PB2.
High, if you want a 0 there, PA1 and PB1 should be high low.
Okay.
No, get a 0 there.
Yes.
That means
I is high.
that means you want it 0, 8. Right?
Right.
0, 8 what?
0, 1.
0, 1. See?
Mhm.
That means you want that to be a 0 and that to be a 1. But that's not affect into part of fail. Okay? Only thing I want you to understand, when I call a function enable output U6 enable, that means I want pin 1 to be 0. And another one, U7 output enable. Then you go into the schematic, U7 here. output enable. That means pin 1 and 19 have to be 0. And basically, they will be controlled by PB pin 6. Okay. And also U4 pin 5, U4 pin 6. Okay. So if you set the PB pin 6 equal 1.
1.
Okay. So this is a NAND. They will be 0 depending on this side. Okay. If U4 pin 6, U4 pin 5 is 1 and 1. Okay. Then that should be 0. 0, I'm sorry, 0 here.
Mhm.
And you get 1 here.
Right.
1 and 1. You can get
A
0. So in this function, they say write to port B. What you think number? Who know?
0x0. Have a look at this.
0x22.
Okay, 0x to 2. Okay. That means you get 2. Let's see, U6, U7 right here. Okay. You want that to be a 1.
1.
And that 1, you get that to be
A 1.
a 1. So that's why you get 2. So basically, after you're done on this one, on part, then you will be develop your function definition. They including everything here. Okay. And then you can see in here, I already telling you what supposed to be. First one, that number 1, you call serial. That's a function, my function. I want to converting 5 to parallel. Then I calling enable U3. Then I calling that validate. That validate here in the path you can see. Tell the computer read port C and set go or no go. Okay, pass or fail. And that number 2, I said that's the same thing, different data AA. And when you go to that number 3, that U6, U7, U4, you think here. Okay, that number 3. You call this function. Go enable U3. Go U6 block. Go U6 output enable. Go enable U7. Contact validate. What that means? If you're looking on the schematic, what we try to do, you write data serial 55 or AA. They go here and they go to out here. Okay, they go to at this point. You try to let that go to U6. Okay, and let go to U6 to get 2 function. Output U6 enable. You need to enable U6. That means apply the clock here and the data coming out. Then I set also enable U7. So the data row appear, wrap did go into here. Okay, then they go to port C. Basically, data will be sent to output U6, go back to U7 and read it. If this static fail, there can be problem U6. There can be problem with U7. There can be problem with U4 and U9, U10. Okay, so that means after you're done on those tests, they almost cover U1, U2, U3, U5. No, U5. U2, U3, part of U4, U6, U7. The last one, memory. Memory here, it's a very simple thing. To get memory, you need to apply a thread. You need to apply data. And you write to the memory. Okay? And later on, you want to verify, you apply a thread, whatever thread, and you read data out. Okay? And they will be verified, right or wrong. So you can see, by looking into the connector here, you get both sides. That means writing data go this way, reading data going out. Okay, so when you're writing, data will be go to U6, go to here. Okay, when you're reading, data coming out from memory, they go to U7 and they go to port C.
And PB5 will change the values on those memory pins.
Right. That means try to see how far you can go. Okay, now, Mr. Smith asking me on that one here.
Right.
That is U7. Okay, you have to follow that. They will take care of that.
Yeah, you enable use. Right.
That means you enter data. Okay.
Enable U3, so that's 0, 0, clock. Let me look at the schematic.
Sometimes I'm not writing here, not asking for path fail, the thing that we already done before.
Right.
Okay. Now, in the memory, I given you the function definition. Write a thread to memory, integer ADD. So what inside, they will be write to port D, enable U3, call the serial to parallel with whatever a thread here, they will be part in here. And U5 last. That means done for write a thread to memory. Next time, I will be go detail on this one here. Then you get the write data to memory. Okay, so the first thing you call the serial data to parallel. And they put the data here, that means whatever data you want, 55, AA, 1, 2, 3, 4, 5, whatever. Then you must enable U3. You need to call a U6 clock and call the function U6 output enable. And after that, you write address, write data, Now you go right to memory. That's what you need to do in your function definition. And also, when you get the address ready, that you want to get the data, you go a read memory function. Okay, and that is the that memory for ADC data. Okay, I already given to you right here. You just copy, paste it out to your function definition. They cover everything. Otherwise, now you not get along with that, you cannot do it now. Okay, and the last one, then random data to the memory. That means you can derive the data to even location and odd location. And later on you reading out. This one you just copy and paste to your function definition. Okay? And they will be take care everything for you. So you have to get through it. Okay, go through it. Okay. In here, I already given to you. What that number 3? How many functions need to be called? That number 4, that number 5, that memory data 55 at location AA, and that memory data AA. Okay, so I given you step right here. Write both data to address. Write different data, different address. Then now you can read the first address. Okay. Then you can read the second address. And also that ADC data, location 042. Okay. And also I given you function definition, write address to memory, write data to memory, write to memory. You just copy that one, paste it out to your function definition. Okay. And also this is an array will be added into the declaration of the program. Copy the whole thing, paste it out into your program. Okay. This is the function I make it. You have to copy into your function definition to convert it serial data to parallel data. Okay, up to this point, any question to me? You get lost. So try to go into the new one I uploaded yesterday or before yesterday. Then you can get everything. We don't care much about what A, B here. Just a reference. Not using that. So that's why we don't asking everything for pass fail. I just been asking you. Okay. On that one. Part that means you get all of the function definition. Good. To see how much you understand. Okay. Any question to me? Okay, if it's not, good luck. Okay. So We'll see you guys next Friday. Good night.
Good night.
Good night, Mr. Pham.
Good night.
Thank you.
You're welcome.
Gonna take long week, Mr. Pham.
Ha ha. Just copy paste into the program.
Okay, I will try that.
You get any question, any problem? Text to me. I online with you.
For sure.
Okay.
Thank you.
Good night.